1. GitHub Actions, the DevOps engine in your repository. GitHub Actions is GitHub's built-in C/CD and automation framework. It allows you to define event-driven workflows that execute code directly from your repository. For DevOps engineers, this means you can build, test, lint, package, deploy, and monitor applications natively in GitHub without relying on external C/CD systems, unless you choose to. 2. Workflow structure, YAML-powered pipelines. Workflows in GitHub Actions are defined in YAML files, placed under GitHub/workflows/in your repository. Each file defines when to run a workflow, via on triggers like push, pull_request, or schedule, and what jobs to execute. Each job runs in a virtual environment and consists of sequential steps, such as installing dependencies, building code, or deploying to Azure. Each job runs in its own ephemeral runner, a fresh virtual machine, Linux, Windows, or Mac OS, and you can also use self-hosted runners for performance, cost control, or security. 3. Runners and environments. The GitHub-hosted runners support popular environments out of the box. A typical Ubuntu runner, for example, comes pre-installed with Node.js, Python, Java, Docker, Terraform, Azure CLI, Kubernetes tools, and more. You can also create your own image or use Docker containers to standardize the environment across workflows. For advanced workflows, GitHub supports matrix builds, allowing you to run the same job across multiple OS versions, language versions, or configuration combinations. This is especially useful for testing compatibility across environments. 4. Secrets and security. Secrets management in GitHub Actions is robust. You can define secrets at the repository, organization, or environment level. These secrets are encrypted and can be injected into workflow steps via environment variables. For example, your C job can use a GitHub Actions secret to authenticate with Azure, AWS, Docker Hub, or a private API. For deployment pipelines, GitHub supports environments with optional manual approvals and deployment protection rules, ideal for gated production deployments and compliance requirements. 5. Reusable workflows and composite actions. To enforce dry principles and modular architecture, GitHub Actions supports reusable workflows and composite actions. This allows teams to centralize common logic, like build and test jobs, or container push steps, into shared repositories, making pipelines easier to maintain and audit. Reusable workflows can be called with inputs and secrets, and composite actions can wrap multiple shell or script commands into a single logical unit. 6. Artifacts, caching, and dependencies. GitHub Actions supports build artifact uploads and dependency caching. Artifacts are useful for passing files between jobs, for example, compiled binaries or test results. Caching speeds up workflows by persisting build tool dependencies between runs, like node_modules, pipcache, or ~/.terraform. For example, Terraform plans, Docker images, or compiled JavaScript bundles can be uploaded at the end of one job and downloaded in another, even across different runners. 7. Integration with Azure and other cloud providers. GitHub Actions integrates tightly with Azure. Using the Azure/login and Azure/WebOps deploy actions, you can authenticate with Azure via Service Principals or OIDA and deploy apps to App Service, Azure Kubernetes Service, AKS, Function Apps, or even ARM/Bicep deployments. Beyond Azure, GitHub Actions has marketplace integrations for AWS, GCP, Kubernetes, HashiCorp tools, Docker, Helm, and many others. You can mix these actions into your workflows without writing custom logic from scratch. 8. Triggers and events. Beyond push and PR. Workflows can be triggered by far more than just commits and pull requests. GitHub Actions supports event-driven automation for a wide range of activities: issue creation, release publishing, new tag creation, comment activity, repository dispatches, and even scheduled cron jobs. This turns your repo into an event-driven automation hub, not just a build system. For DevOps engineers, this is a powerful tool to automate non-code workflows like rotating secrets, syncing config files, or auto-tagging releases. 9. Observability and debugging. GitHub Actions provides logs for every job, step, and command executed. You can view logs directly in the UI or download them for deeper analysis. To aid in debugging, GitHub supports job status annotations, masking of secrets, and debug mode for inspecting environment details during workflow failures. If a job fails, you can use job outputs, expressions, and conditional steps to handle recovery or fallback logic within the workflow itself. 10. Limitations and cost considerations. For public repositories, GitHub Actions is free and unlimited. For private repositories, Usage is metered by minutes, based on runner type, Linux, Windows, Mac OS, and your billing plan. There are also limits on storage, job duration, concurrency, and number of secrets, which DevOps teams should monitor to avoid bottlenecks in large-scale C/CD setups. In summary, GitHub Actions is more than just C/CD. It's a full workflow orchestration engine integrated deeply into the developer lifecycle. It gives DevOps engineers fine-grained control over infrastructure and software automation with built-in security, scalability, and flexibility. If your source code lives in GitHub, your automation probably should too. Let me know if you'd like a breakdown of specific workflows like deploying to Azure, building Docker images, or running Terraform plans with GitHub Actions. Comparing GitHub Actions and Jenkins is essential for any DevOps engineer evaluating C/CD tools for scalability, maintainability, and cloud readiness. Let's go through this in a structured narrative, focusing on real-world technical and operational differences. 1. Origins and philosophy. Jenkins is one of the oldest and most flexible C/CD platforms. It's open source, self-hosted, and deeply customizable. You install and manage it yourself, on a VM, inside Kubernetes, or as a container. Jenkins was built for flexibility across many tools, languages, and workflows. GitHub Actions, on the other hand, is a native GitHub C/CD solution, integrated directly into the GitHub ecosystem. It emerged more recently, with a modern, cloud-native architecture, tightly coupled with GitHub repositories, and designed to automate any workflow, from code build and test to deployments, cron jobs, and infrastructure automation. So, while Jenkins is a build anything, anywhere platform, GitHub Actions is a build right where your code lives service. 2. Setup and maintenance. With Jenkins, you manage the infrastructure. That means provisioning the servers or containers that run Jenkins, installing plugins, maintaining Java environments, configuring security, and handling upgrades. This gives you full control, but also comes with a significant maintenance burden. GitHub Actions, by contrast, is fully managed. You write your workflow YAML files in the repository, push your code, and GitHub takes care of provisioning and destroying runners. There's no server to manage. You get instant scaling and updated build environments with pre-installed tools like Node, Python, Docker, Terraform, and more. 3. Plugins versus Marketplace. Jenkins has a massive plugin ecosystem, thousands of them, covering almost every tool you can think of. But many plugins are outdated, fragile, or incompatible with each other. Managing them can feel like dependency hell if you're not careful. GitHub Actions uses a GitHub Marketplace, where integrations are distributed as shareable, versioned actions. These are small, reusable pieces of automation written in JavaScript or Docker. They're often more lightweight and easier to maintain than Jenkins plugins, though the overall number is smaller, but growing rapidly. 4. Pipelines, syntax and design. Jenkins pipelines are written in Groovy-based declarative or scripted syntax, which can be powerful but verbose and error-prone. Complex pipelines often require deep Jenkins DSL knowledge or plugins like shared libraries. GitHub Actions workflows are written in YAML, which is easy to read and version with your code. Each job runs in its own container or VM and is composed of steps that call actions or shell scripts. GitHub also supports reusable workflows, similar to shared libraries but easier to manage. 5. Integration with Git and SCM. This is a major difference. GitHub Actions is deeply embedded in the GitHub platform. It responds instantly to Git events like push, pull_request, tag, release, and issue. It has first-class access to repository metadata, secrets, commit history, and GitHub API context. Jenkins supports GitHub too, but it requires webhook configuration or plugins like GitHub integration. The setup takes more work, and security can be harder to maintain, especially in a multi-tenant or enterprise environment. 6. Scaling and runners. With Jenkins, you scale manually by adding more agents, build executors. These can be physical machines, Docker containers, or Kubernetes pods. You manage the provisioning logic via plugins like Jenkins Kubernetes plugin or Jenkins Swarm. GitHub Actions provides GitHub-hosted runners automatically, but also supports self-hosted runners if you need custom environments or control over execution. These self-hosted runners can be auto-scaled in Kubernetes using tools like Actions Runner Controller. GitHub-hosted runners scale instantly, but are ephemeral and limited by quotas. Jenkins lets you scale persistently, but that's your responsibility to manage. 7. Security and secrets management. Jenkins requires manual configuration of secrets via plugins or credential providers. Secrets can be injected into jobs, but managing permissions is less intuitive and centralized. GitHub Actions has built-in secrets management, where secrets are stored at the repository, environment, or organization level. Access control integrates with GitHub's airbag and branch protection, making it easier to manage securely, especially across teams. 8. Observability, logging, and debugging. Jenkins has customizable logging, and you can store build artifacts and reports over time. But setting up dashboards, performance monitoring, or log forwarding requires additional plugins or integrations. Github Actions provides real-time logs in the UI for every job and step. It automatically masks secrets in logs and offers contextual UI integration with pull requests and commits. It doesn't yet offer deep performance metrics or historic logs, unless you forward them to external tools, for example, Datadog, ELK, etc. 9. Pricing and cost. Jenkins is free and open source, but the cost is in infrastructure. You pay for the VMs or cloud resources to host it, plus engineer time to maintain it. GitHub Actions is free for public repositories. For private repositories, it's metered by minutes, based on runner type and plan. For enterprises, you can use self-hosted runners to avoid per-minute charges. So GitHub Actions is cheaper in terms of ops overhead, but Jenkins may be more cost-effective at scale if you already manage infrastructure. 10. When to use what? If you're working in a GitHub-centric workflow, want low-maintenance C/CD, need fast integration with cloud platforms, or are deploying from source-controlled infrastructure code, Terraform, Kubernetes manifests, etc., GitHub Actions is often the better choice. It's fast, clean, integrated, and easy to automate end-to-end workflows. However, if you need deep customization, control over the full pipeline runtime, or you're managing highly specialized workloads in a hybrid or on-prem environment, Jenkins offers the ultimate flexibility. It's also still preferred in many legacy enterprise environments where GitHub isn't the central SCM. Setting up C/CD for a Node.js application using GitHub Actions is a straightforward and powerful way to automate your entire development lifecycle, from code commit to deployment. Here's a step-by-step guide, with clear explanations of each stage in the process. Step 1. Project Structure Assumption. We'll assume your Node.js app has a typical structure: src, tests, package.json. The GitHub Actions workflow will live in github/workflows/ccd.yml. Step 2. What the workflow will do. We'll create a GitHub Actions workflow that performs 1. C. Continuous integration. Trigger on every push and pull _ request to main or develop. Set up Node.js. Install dependencies. Run lint, test, and optionally build.to. CD. Continuous deployment. Trigger only on push to main. Deploy the app, for example, to Azure, AWS, or a Docker registry like GHCR or Docker Hub. Step 3. The C/CD workflow explained. In YAML terms, create a file named github/workflows/ccd.yml in your repo with the following logic. Trigger configuration. We define when the workflow runs, on pushes and PRs to specific branches. C job. We use an Ubuntu runner. Set up Node.js using GitHub's official action. Install packages, then run lint, test, and build scripts defined in package.json. CD job. Optional deploy. This can deploy to Azure App Service, upload a Docker image, or trigger a webhook depending on your needs. For this, you typically use a secret, like an API key or token, stored securely in GitHub Secrets. Example C/CD workflow description Bonon. When a developer pushes code or opens a pull request to the main or develop branch, GitHub Actions spins up a fresh Ubuntu environment.to. It installs the specified version of Node.js, for example, V18, restores npm or yarn dependencies, and runs npm run lint to catch code quality issues. Then it runs tests using npm test, which might be powered by Jest, Mocha, or any test framework. If tests fail, the pipeline fails, and the PR is blocked from being merged pot 4. Optionally, the workflow runs a build step, for example, compiling TypeScript, bundling a frontend, or transpiling source code pot 5. If the code is pushed directly to main, typically protected with branch policies, a second job runs that authenticates with your cloud provider and deploys the app 6. This deploy step could push a Docker image to Docker Hub or GitHub Container Registry. Deploy to Azure App Service using Azure/WebOps deploy at v2. Deploy to AWS using AWS Actions/configure AWS credentials. Trigger a webhook or update Kubernetes resources with kubectl. 7. Secrets like cloud credentials or registry tokens are injected securely via GitHub Secrets, without exposing them in logs. Common deployment targets. Azure App Service. Use Azure/login and Azure/WebOps deploy. Docker Hub or GitHub Container Registry. Authenticate and push images using docker/build push action. Kubernetes. Use Kubernetes action, kubectl, and context switching. Heroku or Vercel. Use their respective GitHub actions.